When determining the continuity of a function, it's helpful to know about classifications of certain functions and whether or not they fall into automatically the criteria for continuity. So we have a theorem, which will be very helpful for us. The following functions are continuous at every point. Now here's the important part, it's in their domain. Okay? So if you have a polynomial, you can say, yes, this will be continuous on every part of its domain. The same with the rationals, the radicals, the exponentials, the logarithmic, the trigonometric, and the inverse trigonometric functions. So that brings us to this example. For what values of x are the following functions continuous? For f, what we have, this is a rational function. And we know that for rational functions, the domain is the set of all x. Their domain. It's the set of all x, and in words, we would say, well, it's the set of all x such that the denominator does not equal 0. In specific for our function, what that means is the value of x that will make the denominator go to 0 is -4. So the domain for here is the set of all x such that x cannot equal -4. And therefore, this function is continuous. For every value of x that is not equal to -4. G of x is a radical function, and we know with radical functions, even radicals, that we have to make sure that the radicand stays greater than or equal to 0. So x minus 5 has to stay greater than or equal to 0, which means that x must be greater than or equal to 5. So this function will be continuous for all values of x greater than or equal to 5. Lastly, we have a polynomial, and remember that the domain of polynomials is -infinity to infinity, that is all real numbers, and so polynomials are continuous for all real numbers.